Hello and welcome to another episode of the Identity Navigator. My name is Rohit. Today, let's deep dive into an approach to IAM which could be useful in architecting IAM systems and operations. Let's talk about self healing IAM systems, which could be considered a business centric framework. Now, we all know that identity and access management systems are critical to enterprise security. Yet, they remain susceptible to failures caused by misconfigurations, policy drift, and evolving cyber threats. A self healing IAM system leverages automation, artificial intelligence, and real time analytics to autonomously detect, diagnose, and remediate identity related risks. So, let's explore the architecture of self healing IAM, identifying the components that could be autonomously created, and examines how such system can be extended to enterprise policies, ensuring continuous security, resilience, and compliance. Now, traditional IAM systems depend on manual intervention for incident detection and remediation, making them slow to respond to emerging threats. A self-healing IAM systems mitigates these challenges by implementing automated corrective mechanisms, right? So now what are these mechanisms automating, right? Where is that baseline? And that baselines could be looked at from the point of views of policies, standards, and control solutions. So let's quickly look into what these things are. Policies are high level directives that defines an enterprise security objective, rules, and governance framework. These policies provide strategic guidance for IAM implementations, dictating expectations for identity lifecycle management, authentication, authorization, and compliance. Let's take an example. An enterprise security policy may mandate that all privileged accounts must utilize multi factor authentication. Right. Now, what are standards? Standards establish technical and procedural requirements to enforce policies. They provide consistency and ensures regulatory compliance across identity and access management procedures. For instance, a standard related to MFA may specify that authentication mechanisms must include biometric verification, hardware tokens, or one-time passwords. Control solutions translate standards into enforceable mechanisms by defining specific technical implementation and operational procedures. These includes IAM tools, configurations, and enforcement mechanisms that uphold security standards. For example, a control solution may involve integrating MFA with enterprise identity provider to enforce authentication rules effectively. Now, control solutions are intrinsically linked to standards as they operationalize compliance requirements and ensure adherence to security best practice. Now, understanding these policies, standards, and control solutions for IAM is critical. This is where I've seen a lot of excellent implementation engineers not pay that level of attention to these things, right? But if you are in IAM domain, work with your GRC or risks team or whoever owns the standards in your organization to identify what those standards are, why are those standards being created, and what are the control solutions associated with each of the standards, right? So now after we have looked into policies, standards, and control solutions, let's look into an example of an IAM's self-healing policy. A self healing IAM policy extends enterprise security policies by embedding automation and intelligence into identity governance. For example, if an enterprise policy mandates that inactive accounts must be disabled within 30 days, a self healing IAM system can automate the detection and deactivation of such accounts. The standard supporting this policy might define inactivity threshold, while the control solutions could include automation scripts and monitoring mechanisms that enforces account deactivation without human intervention. Now, this idea isn't entirely new, right? You could tell me that uh, most of the modern ITDR solution does exactly the same thing that I'm telling you right now. So what's novel about this self-healing IAM framework, or why is this a new concept, right? So it's not like a new concept. How I would structure my argument is a zero trust framework, arguably, but according to me, is the next iteration of defense in depth, right? But it allows you to be more intentional in terms of what are the security controls that you are putting into place during the journey uh, of a transaction within your ecosystem. So, in the same way, ITDR is a part of the self healing framework that we are talking about today. This self healing IAM framework is actually an extension of existing practices like chaos engineering. And we will talk about it more in terms of how do we make sure that our environment is has an uptime that it is expected. It is an extension of detection engineering, high availability, disaster recovery, and obviously modern ITDR system. So rather than looking at these things in silo, say for example, how, is my cluster adding more Kubernetes pods when the load is more, right? What is my backup and recovery options? What are my high availability options, right? Some sort of chaos engineering, some sort of detection engineering, automation in terms of policies are implemented just how they are implemented in any modern ITDR solution, and they could be implemented at scale. The combination of all of these things would allow you to create a self-healing IAM system, right? So we are already doing these things in some capacity in silo, or at least I would expect you all to be doing it, right? But thinking it in this terms, in this framework, allow us to be more intentional about it. So now when you are looking into an ITDR system, you're just not looking into based upon their capabilities. Hey, I can only integrate with Azure or AWS and GCP, and that is why I'm automating just that part of it. Identity threat detection and response is not just cloud identity threat detection and response, right? So now you are looking at it across your ecosystem. You are not dependent upon what the product is giving you. Rather, you are asking the product to give you a system so that you can create those self-healing IAM, or you can implement that self-healing IAM within your ecosystem. So, what's different here is that we are focusing on identity and access management at a practice level rather than in terms of projects, concepts, or technology. Instead of just looking at permissions and identities like traditional ITDR system, we are considering IAM as a whole and treating it as a key part of overall architecture. Now, a self healing IAM system is an intelligent security framework that continuously monitors, adjusts, and remediates identity and access controls to maintain compliance and security integrity autonomously. So, what would be the core principles of such a system? I would say automated detection, where an AI driven anomaly detection mechanisms identify misconfigurations, unauthorized access attempts, and policy violations. Now you can play around with these misconfigurations. What are the actual configurations that you would want to look at? It could be very simple as how an access is configured to all the different type of configurations that you could think of, right? So the scope is in your hand, but the framework is defining that you can look into an anomaly detection tool to identify these misconfigurations, unauthorized access, policy violations, etc., etc. Another core principle would be autonomous remediation, where automated corrective actions enforces security policies dynamically without requiring manual intervention. Now, this would be for a very mature system, right? Because you do not want to cause outages by self-correcting anything, right? So start small but dream big, right? And that sounds such cliched when I speak about it, but in terms of do not just have friction for the sake of having friction, right? Get your maturity level to a place where you can have these automated corrective actions. Another core principle would be adaptive learning, right? And this would be the maturity journey that I'm talking about, where the machine learning models continuously refine security responses based on evolving attack patterns and enterprise behavior. And then last but not the least, this is where it just deviates away from a traditional ITDR system, is resilience and recovery. That would be the fourth core principle, where the ability to automatically restore IAM components to a secure state following failures or security breaches, right? So it could be an outage based upon an human error. It could be an outage because of system failure, or it could be an outage because of a security breach, right? So that resilience and recovery will depend upon the type of this outage, but you could have a system created that automatically restores IAM components in these cases, or data in some cases, right? So let's look at some of the components that could be healed. Obviously, user access controls, where automatic revocation of excessive permissions based on least privilege principles. You could look into who is using the access. If the access hasn't been used for 90 days, you could look into excessive access and things like that. Self remediation of orphan accounts to mitigate insider threats. And then another thing you can look into is just in time access provisioning based on risk aware behavioral analytics. Another component could be policy enforcement, where you are enforcing the policies of least privilege in real time scenario. Another example of policy enforcement could be dynamic recalibration of role based access control and attribute based access control based upon contextual risk analysis. Next component that we'll talk about is authentication and authorization mechanisms. So, auto remediation of MFA failures, or risk adaptive authentication that adjusts security measures in real time, right? And we do a lot of these things today, or self healing API authentication mechanisms to prevent service disruptions. In terms of IAM infrastructure and configuration component, we could look into automated rollback of IAM misconfigurations to ensure continuous security, self-healing IDP services to maintain authentication availability, right? Identity provider, and proactive identification and resolution of directory synchronization anomalies. Other could be compliance and audit logging, where automated correction of logging failures to maintain compliance with regulatory requirements, and continuous audit trail validations to prevent log tampering or data loss, right? So one of the most catastrophic IAM failure is the unintended or malicious mass deletion of directory objects, which can result in widespread access disruptions and security vulnerabilities. A self-healing IAM system prevents such incidents through a multi-layered approach. Uh, the system continuously monitors directory object deletion trends to establish a baseline, and any deviation from normal behavior, such as an unusually high number of deletions within a short time frame, triggers an alert. So, this could be considered as a baseline and anomaly detection. Friction and conditional approaches. If a deletion request exceeds predefined threshold, let's say more than 5% of the directory objects in a given period, the system introduces friction requiring step up authentication or additional approvals. Automated rollback mechanisms. If unauthorized or anomalous deletion occurs, the system automatically restores deleted object from a secure backup, ensuring minimal downtime. Risk adaptive responses, where the IAM system dynamically adjusts access controls, temporarily restricting permissions for accounts, initiating mass deletions until a security review is conducted. So I'll just take away the permissions from that account who is requesting that. That could be a Python script, right? Who is requesting these mass deletions. And then comprehensive logging ensures forensic visibility, enabling rapid investigation and policy adjustments to prevent reoccurrence. Right. So these self-healing capabilities reduces the risk of accidental or malicious deletion of critical directory objects and reinforcing IAM resilience. So IAM resilience is another concept that a lot of us are familiar with. That is why I said self-healing IAM framework is not a groundbreaking new concept, right? It's sort of like the next iteration and thinking of things together, right? We took an example of, or we spoke about zero trust earlier, and that is how I would look at it. So self-healing IAM systems extend the principles of chaos engineering by proactively testing and reinforcing IAM availability. Chaos engineering involves intentionally inducing controlled failures to evaluate system resilience. Right? In the IAM context, self-healing mechanisms ensures robust access management by automatically detecting and mitigating disruptions, policy misconfigurations, or security anomalies. We've also talked about this concept during the episode of ITDR, where we talked about that honeypot concept or the second iteration of honeypot concept. This chaos engineering is just taking that concept. It's a very well known concept introduced by Netflix, if I'm not wrong, and just making it sure and ensuring it that it is applicable to IAM systems as well. And now, to prevent major IAM outages, self-healing IAM system establishes a baseline of normal identity and access behaviors, including authentication trends, role-based entitlements, authorization workflows, number of deletions, and any deviation from this baseline trigger automated corrective actions. Right now, when anomalous activities are detected, the system should introduce security friction, such as step up authentication, temporary access restriction, or automated policy adjustments to prevent escalations into system wide failures. For example, if an IAM system detects a surge in failed authentication attempts, due to an overloaded authentication server, it can dynamically reroute authentication requests to an alternative identity provider or enforce additional security checks to maintain seamless access. Right? So you're looking at it as to how we are using the same concepts, but we are looking at it together in a 360-degree view rather than looking at them in silos. Right? So when you are looking at your system, think of what could go wrong and how can I make sure that I can quantify what is wrong, or the system can quantify what is wrong, how I can prevent that wrong things does not take place, and if the wrong thing takes place, how can I restore it back to the working model, right? And these are the core principles or the pillars of a self-healing identity system. Now, you're basically giving away the keys to the kingdom, right, to a framework. Or so how do you trust it, right? And that is why I say that deploying a self-healing IAM system requires a high degree of trust, as it grants automation controls over identity security. To ensure reliability, we must implement the following trust mechanisms, right? Uh, Governance and oversight. Establish formal oversight structure and accountability frameworks, and introduce approval workflows for high risk identity management actions, especially at start. Use continuous validation techniques such as canary deployments and A/B testing, right? Deploy remediation actions in controlled sandbox environment before applying them to production. Implement rollback mechanisms to reverse unintended system changes, and establish manual intervention points for high risk remediation processes. Maintain immutable logs of self healing actions for auditability. This is really important because as we are maturing the systems, we need to understand everything that the system carried out, and provide security dashboards for real time monitoring and anomaly reporting. Assign confidence level to automation based on risk assessment framework. It's not either you trust everything or you don't trust anything, right? Every automation within this framework has to have a confidence level assigned to it, right? And once your confidence level reaches your risk appetite, that is when you can actually productionize it. And that risk profile or risk appetite would depend upon your risk assessment frameworks. And adaptive adaptively escalate security decisions requiring human interventions. Again, it's not 0 and 1, right? It's not like every security decisions require human intervention. That process needs to be smart as well, because otherwise it would just be too much noise. Now, by embedding these trust mechanisms, enterprise can confidently deploy self-healing IAM systems without compromising security, compliance, or availability. Remember, a self-healing IAM systems enhances enterprise security by automating identity governance. You're looking into things of who has access permission, potentially uh, helping to streamline your compliance processes or attestation processes, right? Very much in the realm of ITDR or CSPM or SSPM or any other type of abbreviation that you want to throw at it. But it also mitigates operational risks and ensuring adaptive security resilience. And a lot of it that we are doing right now, risk-based conditional access policies within intra-system or non-usage of known passwords are things like this. Chaos engineering, high availability. These are all the examples of a self-healing IAM system. Backups, right? Another example of a self-healing IAM system. So by leveraging AI, ML, real-time analytics, and a bunch of technologies that we already have or the product offers, we can create dynamic self-correcting identity framework that reduces administrative overloads and improves security postures. Now, in future podcasts or episodes, we should, or hopefully, we should explore AI driven policy adaptation. How does it integrate with decentralized identity models and potential extension of this framework? But for now, I hope that it resonated with you. Thank you for listening. You can reach out to me via LinkedIn or can always send me an email at theidentitynavigator@gmail.com. Both of this information I will put in the show notes. Until next time, this is Rohit, your identity navigator.